Welcome students, this is Pankaj Singh, askIITians faculty, working with askIITians since last 3 years. Today we are going to start a new chapter, hydrogen. As the name suggests, hydrogen. In this chapter we are going to study about each and everything about hydrogen. We'll study its properties, its preparation, then we'll study about its compound, their properties, their preparation. We'll study each and everything related to hydrogen. So let's start. Hydrogen. Okay, so let's start the discussion about hydrogen. Okay, so as we are very well aware of the fact that hydrogen is the first member of our periodic table, and it is the simplest element present on earth. And apart from this, hydrogen is actually the most abundant element in the universe and the third most abundant element on the earth's surface. That means it is that element which is present in largest amount in the universe, and on earth's surface it is the third largest element present on the earth. Okay, next is it is the simplest element which with only one electron in its orbit around the nucleus and having only one proton, and it exists as H2. Actually, what is the atomic number of hydrogen? You know, it is 1. Okay, Z is equal to 1, and also atomic mass is also 1. That means it has 1 electron, 1 proton, and there is no neutron. So it is the simplest one with 1 electron, 1 proton, no neutron. So mass is also 1, atomic number is also 1. And it basically exists in diatomic form in the form of H2 dihydrogen. And actually it is very important these days because hydrogen can be used as a fuel in future. Because okay, for this time we are mainly dependent on carbon fuels for energy like petroleum, coal, etc. And when we burn carbon containing fuel, we get carbon dioxide, which is a pollutant, and it is a major issue for the environment as it causes global warming. So if we burn hydrogen, we get very large amount of heat, because we know that energy present in sun is mainly because of hydrogen. So hydrogen can be used as a fuel, we'll get a large amount of energy, and the byproduct which we will get would be water. So there is no pollution, it is a totally clean source of energy and highly efficient also. So we are looking toward the hydrogen for the future fuel, and we will use hydrogen for different purposes, basically for fuel for obtaining energy. And this branch of study which basically focus on hydrogen as a fuel is known as hydrogen economy actually. Now position of hydrogen in periodic table is a main concern, because we are not able to specify any specific position for the hydrogen in periodic table, because its properties are similar to alkali metals also, group 1 metals, as well as those of halogens also, group 17 metals. So it is a big problem and a point to be discussed, that what should be the position of hydrogen in a periodic table. Okay, so hydrogen is the actually first element of periodic table, but its position in the periodic table has been a subject of discussion for the past few years due to its similarity with both halogens and alkali metals. A proper position could not be assigned to hydrogen either in Mendeleev's periodic table or also in modern periodic table. In some properties it resembles with alkali metal, and in some other properties it resembles with halogens. So hydrogen cannot be placed both in group 1 and group 17 with alkali metals and hydrogens and halogens respectively. Now the next point is isotopes of hydrogen. We know what are isotopes. Isotopes are isotopes are the atoms of same element which have same atomic number but different atomic masses because of different number of neutrons present in them. So there are 3 isotopes of hydrogen basically: protium H1 with 1 electron and 1 proton only. Then next we have deuterium, in which there is 1 electron, 1 proton, as well as there is 1 neutron. And then we have tritium, in this we have 1 electron, 1 proton, and we have 2 neutrons. So total mass here is 3, here it is 2, and in this case it was 1 electron, 1 proton, so the mass was also 1. So there are 3 isotopes of hydrogen: protium, deuterium and tritium. Okay, now these all differ from each other in respect of number of neutrons present in the nucleus, as we have discussed. Protium does not contain any neutron. Deuterium, which is also known as heavy hydrogen, contains 1 neutron, while the number of neutrons in the nucleus is actually 2. It has deuterium contains 1 proton, while the number of neutrons are 2. Okay, so let me just correct this once again. The deuterium contains 1 neutron, while tritium contains 2 neutrons. Tritium is basically radioactive and it emits low energy beta particles. Now we have to discuss that how does actually I have informed you that hydrogen resembles with both alkali metals and as well as halogens in its properties. Now how do it resemble with alkali? Let's have a look. So first, it resembles with alkali metals in terms of its electronic configuration. Hydrogen has 1s1 electronic configuration. It has only 1 electron in its outermost orbit. Similar is the situation with the rest of the alkali metals. They all have ns1 type electronic configuration. Next is electropositive character. Now like alkali metals are metals, so they are electropositive. That means they can easily donate an electron. Now just like alkali metals, hydrogen also loses its only 1 electron which is present in its atom to form hydrogen ion. We know we have sodium. Sodium can easily donate an electron to form Na positive. Similarly, lithium can also easily donate an electron to form lithium ion, and in the same way, hydrogen can also donate the 1 and only electron present in its orbit to form hydrogen ion. So this is the way actually hydrogen resembles with alkali metals in its electropositivity. Next is oxidation state. Like alkali metals, hydrogen is also shows +1 oxidation state. We have just seen that just like alkali metal, it also loses 1 electron to form +1 oxidation state. Next is reducing character. Actually alkali metals are metals, that means they can easily donate electrons, that means they can easily oxidize, or we can say they can easily reduce others. So they are good reducing agent. Metals are good reducing agent, and just like alkali metals, hydrogen is also a very good reducing agent. An example is from here. If we heat Fe3O4 with H2, what we get? Iron plus water molecule. So we can see that iron oxide is being reduced into iron. So hydrogen is a good reducing agent. Similarly, copper oxide when heated with hydrogen also results in formation of copper and water. So it acts as good reducing agent also. Okay. The next is combination with electropositive element. Just like alkali metals, hydrogen combines with electronegative elements. Okay, metals, we know all the metals are electropositive in nature, so they can easily combine with all the metals are electropositive in nature, so they can easily combine with electronegative elements to form ionic compounds. So just like alkali metals, hydrogen also combines with electronegative elements such as halogen, oxygen, sulfur, etc. to form compounds with similar formula. Just like when it's combines with halogen, like we can see HCl, HF, HBr is formed. With oxygen it forms H2O, H2O2, with formula it forms H2S, and so on. Now we have discussed that how is it similar to the alkali metals. Now we will see that how does it differ from alkali metal. First is ionization enthalpy. Actually ionization enthalpy of alkali metals should be very low because they are metals, they are electropositive, so their ionization energy would be low. But the ionization enthalpy or ionization energy of hydrogens is high. it is very high as compared to the ionization enthalpy of alkali metals. So this is the first difference. Next is existence of H negative. Actually, it has been established that H negative ion does not exist freely in the aqueous solution. Now this is because of the fact that it has a very small size as compared to normal atomic and ionic size. Thus it exists in aqueous solution in the form of hydrated proton like H3O positive. Actually it is H positive, existence of H positive. We know that sodium positive and Na positive exist, lithium positive also exist, but similarly H positive cannot exist actually. This is because of the fact that this hydrogen is very small in size, thus removal of one electron requires first of all very large amount of energy, and if it is removed then this proton or H positive becomes so reactive that it exists only in aqueous state, and in aqueous state also it combines with water molecule to form H3O positive. So it is found always in H3O positive form and not in H positive form. So this was the second difference actually. And alkali metals mostly exist as hexahydrate ions but not the hydrogen. Now difference in halides is another thing actually. Hydrogen halides are different from the halides of alkali metal, although they have similar molecular formula. For example, if we talk about HCl, it is covalent, but if we talk about NaCl, it is ionic. On the other side, HCl is gaseous while NaCl is solid. So this is how hydrogen basically differs from alkali metals. Now let's have a look at that. How does hydrogen is similar to halogen, or how does it resemble with halogens or group 17 elements? The first is again ionization enthalpy. Ionization enthalpy of halogens is very high because of small size and they require only one electron. So their ionization enthalpy is very high, and so is the case with hydrogen also. Next is existence of H negative. It has been established that H negative ion does not exist in free state. It is actually about H positive. Okay. So similarly, H positive ion does not exist for hydrogen in free state, as similar is the situation with halogen. Cl positive or F positive does not exist in free state. Say they are very rare to exist, and that is why it also resembles with halogens. Okay, next is, okay, we have talked about ionization enthalpy, so we can see from here that ionization enthalpy of hydrogen is much comparable with rest of the halogens. So this is how it resembles with halogens in its ionization energy. Now let's have a look at how does it differ from halogens. Okay, we have discussed first of all that what is the similarity between alkali metals and hydrogen. Then we have discussed that what is the difference between alkali metals and hydrogen. Then we have discussed that how hydrogen is similar with halogens. Now we will see that how hydrogen is different from halogens. First of all, it is less tendency to form hydride formation. H negative is hydride ion. We are very well aware of the fact that chlorine negative, bromine negative, fluorine negative, these ions, negative ions, iodine negative also exist very frequently, but H negative does not exist. Hydrogen has very less tendency to form H negative ions. So this is the first difference between hydrogen and halogens. Next is absence of unshared electron. Okay, if I talk about Cl2, we know that chlorine had 1, 2, 3, 4, 5, 6, 7 electrons. Similarly 2, 4, 5, 6, 7 here. So if a bond is formed between these two, still we have 2, 4, 6. Similarly 2, 4, 6 unshared electrons. But it is not the case with hydrogen. They both have only one electron, so they do not have any shared electrons when H2 is formed. So the another difference is absence of unshared electrons. Next is nature of oxides. Actually, oxides of halogens are acidic in nature, whereas oxide of hydrogen is neutral. We are well aware of water. It is an oxide of hydrogen, it is neutral. So oxides of halogens are acidic while the oxides of hydrogen is neutral. And nature of compounds, actually the compounds of hydrogen with halogens, that means hydrogen halides HCl, HF, HBr, Hi are low boiling covalent compounds, whereas alkali halides are high melting ionic solids. Now there is a solved problem that ionization of hydrogen atom would give rise to. Okay, we know there is hydrogen atom and it has only one electron, and if this one electron is removed, we will left with H positive. So ionization of hydrogen atom would give rise to a proton actually only, because it has one proton and one electron and no neutron. So if there is no neutron, so if an electron is removed, we are left only with proton, and that is why H positive is also called proton sometimes. So C is the correct option. Next is the property of hydrogen which distinguish it from alkali metals is actually non-metallic character. All the alkali metals are metals, while hydrogen is not metal, it shows non-metallic characters. So D is the correct option. So students, now we are familiar with the element hydrogen, and we know how it is very critical to assign it the right position in our periodic table, because its properties are similar to both alkali metals as well as halogens. Now next video will move to dihydrogen. So stay tuned.